We have a rectangle. This is a 2, this is a 4, and we have a circle, semicircle, the tangent to the midpoint, and then we have a diagonal, and we want to find the area of this shaded region. Now I want to solve this problem by using a definite integration. Then afterwards, after I find the solution, then I check this answer by using geometry and trigonometry. Okay, now to use integration to find area, we must have a coordinate system, right? So we must put this graph into a coordinate system. So we must find the origin first. Now where's the origin? If we choose this origin, this x-axis, y-axis, then these curves, the straight line, may have an equation based on this system, right? If we choose this origin, then you have a different kind of different equations about the curves and the lines. If you choose this as the origin, and the equation of the line in the circle will be differently. Of course, we choose the coordinate system such that the equation for the curve and the straight lines are simpler, and the integration is easier to be found. Now, based on this principle, I would rather make the graph into this. Well, this is y-axis. This is my x-axis. This is origin. I believe that having chosen the coordinate system like this, then the curve and the straight line, the equations are simpler. So our integrations will be easier. Okay. Now since this is a 4, right? So this is a 2. See? So this is 0, this is a 1, right? And this is a -2. And this is a 2. And this is the center of the circle, semicircle. This is the origin, and this is a straight line, right? Now, let's do one by one. We want to find I want to find the equation of the straight line. Equation of the straight line. Okay, now this is a 2. This is a 1, right? So the gradient, the slope is a -½, right? -½. And the y-intercept is 0, 1. Therefore, the equation of the line, if we're using slope-intercept form, y is equal to -½ plus 1, right? So this is my equation for the line, right? When x equal to 0, y equal to 1. When y equal to 0, x equal to 2, yes. Okay, that's a straight line. Now, for the semicircle, that we need a center. The center is 0, 2. The radius is 2, right? The radius is 2. Therefore, the circle is y minus 2 square plus x minus 0 square is equal to 2 square, right? So y is equal to plus or minus 2 minus square root, right? 4 minus x squared. So that is my equation for the circle. Since our circle is a half circle, right? So we choose the circle below 2. So therefore this is my equation of the semicircle. Is now this is 2, right? Plus or minus. This is 2 minus square root 4 minus x squared. So this is my semicircle, equation of semicircle. That is equation of the whole circle. Right? Now we can start to integrate, right? Okay, let me write the equation first. This equation is y is equal to negative half x plus 1. This circle is y is equal to 2 minus square root 4 minus x squared. Good. Okay, now we can set up integral for the area, right? Okay, good. Now the area, yes, I am missing something. We need a point. We need this point. Okay, how to find this point? To find this point is solve these two equations, right? Solving these two equations. Solve y is equal to half x negative plus 1. Y is equal to 2 minus the square root. Now, I don't want to spend time to find the equation. I think you can easily find the intercepting point, right? So I believe this is the point, right? The negative 2 and 2. Negative 2 and 2 is the negative 2 and 2 is the intersection point. Also, there is another one. The other one is 1.2. 1.2 and 0.4. I did my homework. So solving these two equations, you have 2 points. One is here, one is there. These are intersecting points with semicircle and straight line, right? So this point is 1.2 and 0.4. Okay, so this point is 1.2. Okay, these are just preparatory works, works for my integrations. All right. Okay, now we can start. Okay, the integration, the area have one piece is here under this curve, under the semicircle, and plus the area under the straight line, right? So the area is equal to from 0 to 1.2, and under the semicircle. The semicircle is this equation, right? 2 minus the square root 4x minus square, okay, dx, yeah, plus this piece. This piece is from 1.2 to 2 under this function, which is minus half x plus 1, right? dx. Okay, so So far, the integration, definitely integral has been set up. We just integrate these two, we get the area. Okay, so, well, let me do it slowly. This is a 2, right? X 0.12. This is the first part. It's easy. Minus this one, I think I will let me write small. X is equal to 2 sine theta, right? So this one from x equal to 0 to x 0.1, x not theta. So this will be equal to 2 cosine theta, right? Dx is a d cosine theta, d theta, right? Theta is from x equal to 1 to x equal to 1.2 plus this is a negative x squared over 4, right? Yeah, from 1.2 to 2 plus x 1.2 to 2. Okay. And this one is equal to, this is a 2.4. This is a 4, right? This is a cosine square. Cosine square is a half integral, right? Integral x from 0 to 1.2. X and not theta. Half 1 plus cosine 2 theta, right? D theta. This is a 4 minus 1.2 square. So that is equal to 0.64. Okay, this calculation. And plus 2 minus 1, and this is 0.8, right? Okay, good. This is 3.4 minus 2 times. Now this is theta, right? This is d theta, and this is a half sine 2 theta. Sine 2 theta is 2 times sine theta cosine theta. Theta, x is from 0 to x equal to 1.2. Minus 0.64 plus 0.8. Now, what's the theta? Theta is x is equal to 2 sine theta. Theta is arc sine x over 2. Okay. Now since x is 1.2, so this is arc sine 1.2 over 2. It's arc sine 0.6. Arc sine 0.6 is 0.643. Okay, so this is a 2.4 minus twice. This will be 0.643. Sine theta is sine theta is 2 over x over 2. Okay, this is theta, this is x, this is 2, so this will be 4 minus x squared. So the cosine is this over 2, right? This is 2. Cosine is 4 minus x squared. Okay, x is from 0 to 1.2 minus 6 0.4 plus 0.8. And while you substitute 1.2 here, minus x equal to 0. So after you calculate it, okay, the calculation is 0.314. So that is the overall answer for the area. Well, excuse me for skip the calculations here. You can do it according to this very easily. So the result is 0.314 for this area. Okay. Okay. Let me briefly overlay. Okay, this area is this piece which is under this curve from 0 to 1.2. Right, that is the integration, and then plus this piece. This piece is from 1.2 to 2 under this curve. This curve is this function, right? And then you go over all the details. You find the result is 3.14. Okay, there's a lot of details, but it's not a series, but rather to set up the integral is the most important. All right, the calculation is a trivial. Now, let me verify this answer by using geometry. Okay, now this is the graph we start with. Let me use geometry to do this one. We want to find this area, right? We want to find this area. Yeah. We know that this is 0, this is 2, this point is 1.2. This is 0.4, right? But we put 1.2 to the equation, right? So this, let me write this one. Y equal to negative half plus 1, right? This is y equal to 2 minus square root 4 minus x squared. Okay. When x is 1.2, it's 0.6. Yeah, 1 minus 0 is a good point. Yeah, that's correct. Now we want to find this area. We want to find this area, right? Now this area is this triangle plus this piece, right? The triangle is very easy. This is 0.8, right? It's 2 minus this one. So triangle, the area is equal to half 0.8 times the height. The height is 0.4. So that one is equal to 0.16, right? Yeah. So this piece is 0.16. Now this piece, well, if I join the line here, and this is the line here, don't you think that this is a trapezium? This is a trapezium, right? The trapezium area is equal to, this is a trapezium, this area is equal to this one plus this one, right? This is 2. This is 2, right? This is 2. 2 plus, this is 1.2. Times the half, times the height, the half 1.2, right? This trapezium, this area of trapezium is equal to this plus this times this. This is times half. Yeah, so this is 1.44. Okay. The areas are very easy to be found in this calculation. Okay. Then also that we have this sector. This sector, you know, this sector. This area of the sector is equal to half the angle, right? This angle times the radius. The radius is 2, right? 2 square. That's the area of the sector. That's the piece of sector, right? Yeah. Now, how to find this angle? This angle. This angle is not difficult. Look, this is 1.2, right? This is 2. This is 2. The radius is 2. This is 1.2. So theta is arcsine 1.2 over 2. Okay. Arcsine 1.2 over arcsine 1.2 over 2. This is equal to arcsine 0.6. From the calculator, you know, it's easy to be found. This is 0.643. So then this is half 0.643 times 4. So this area is equal to 1.286. All right. Therefore, this piece is the trapezium minus this sector. So therefore, this is the area of a trapezium minus the area of one sector is equal to 0.154. Therefore, the overall area, total area is equal to this plus this triangle, right? Yeah. So 0.16 plus 0.154 is equal to 0.314. Yeah, that is the answer we got from the integration. Okay. Yeah. Okay, I hope you see all the details, you know. You just need to fill up the calculations. I think this is a very good question to practice the application of a definite integral, which means to find area under the curve. And the variation, we just use geometry and trigonometry, you know, to verify our answer is correct. Okay, Thank you for your watching.